In the last program, we talked about how individuals make rational choices by weighing the costs and the benefits at the margin. Should I have another piece of pizza? Yeah, because after all, the price of one more pizza is less than the happiness that one more piece of pizza will bring. That's what we call the marginal utility. Should I go to college? Yes, because the expected increase in income exceeds the costs. In this episode, we want to be more realistic. First, the amount of goods that individuals can buy are constrained by their income. For most of us, if not all of us, our wants exceed our income. Second, we don't just buy one good, but in fact we buy a number of goods and services. So how do we decide how much to buy of what goods? Well, let's first begin with the budget constraint. Our preferences determine what we want to buy, but our income, in fact, determines what we can actually buy. I may prefer a Volvo to a Volkswagen, but nonetheless I buy the Volkswagen because of lack of income. And in addition, individual scarcity varies from person to person. Some people can afford to buy more goods and services than others, and some people have more time to shop around. The choices available to an individual are described by the budget constraint. A budget constraint shows all the combinations of goods and services which can be acquired given an individual's limitations in income, time, or space. Suppose Andrew earns $2,000 a month from working at a bakery. Andrew has three major expenses: his apartment, his car, and other expenses such as food, clothing, health insurance, and books. Other expenses amount to about half his income, leaving Andrew with $1,000 to allocate between his apartment and car. The Lexus he'd really like carries a monthly payment, including insurance, of $500 a month. The apartment he wants is in a great neighborhood, overlooks the city, but it costs $700 a month. Well, let's review Andrew's situation. The available income is $1,000, the car payment is $500, and the rent is $700. Is that feasible? No. Without going into debt, Andrew's preferred situation is not feasible. Andrew can't afford both the car and the apartment given his budget of $1,000 a month. He must choose a less expensive car or a cheaper apartment or some combination of the two. Well, let's look at some of his options. Option A, income $1,000, car payment $500, rent $600. Feasible? No. Option B, income $1,000, car payment $500, rent $500. Feasible? Yes. Option C, income $1,000, car payment $500, rent $400. Feasible? Yes. Option D, income $1,000, car payment $300, rent $700. Feasible? Yes. Option E, income $1,000, car payment $400, rent $600. Feasible? Yes. Option A is still not feasible, even though rent has been lowered. In option B, Andrew chooses his desired car, moves into a smaller apartment, and is able to pay his bills. Options C, D, and E are also feasible, but notice that in C, Andrew still has $100 left over which can be allocated to other things. In D, he has chosen to keep the good apartment while opting for a cheaper car, while in E, he has taken a slightly less attractive apartment and a slightly cheaper car. We can show Andrew's situation graphically. Notice that option A, which was not feasible, falls to the right of the budget constraint, while option C, which has excess income, falls to the left of the budget constraint. All other options are feasible and all income is completely spent, implying that he is on his budget constraint. By using this diagram, we can distinguish those options, such as option A, that are not feasible from those that are. But this still leaves us with uncertainty over which of the remaining options will be chosen by Andrew. This is where Andrew's own individual preferences become important. But how do we express preferences? How do we express the idea of utility maximization with regard to two or more goods? Well, recall the condition for the purchase of one good occurs where the market price equals marginal utility. That's where the cost of one more unit equals the benefit. In buying two or more goods, we don't equate the costs and benefits for each additional unit at the margin. Instead, we want to ensure that the benefit from the last dollar spent on each good is the same. If it weren't, a person could increase utility by reallocating income.
And now it's time for Chalk Talk with your host, Miss Sarah.
Now we're going to talk about a budget constraint and a consumer named Heather. Heather has an income of $60. She's trying to decide whether to buy compact discs or whether to buy computer games. The price of the discs are $15. Price of the games are $30. If she spends all of her money on computer games, she can buy two of them. If she spends all of her money on compact discs, she can buy four of them. Or she can purchase some combination in between. For example, she can buy two compact discs, which will cost her $30, and then she'll have $30 left over with which she can buy one computer game. The equation for the budget constraint is the price of good X times X. In this case, the price of X, X being compact discs, is 15. And the number of discs she buys can vary. Plus the price of good Y times the amount of good Y she buys. In this case, Y is computer games, and the price of those is $30. These two must add up to equal her income, which in this case is $60. So the equation for this line is represented by this equation here. Now, if the price of compact discs increased, for example, the price of compact discs is now $30, this line is going to rotate inward. Now, if she spends all of her income on compact discs, she can only buy two. If she spends all of her income on computer games, she can still buy two. So this point will stay the same, but the line will shift inward like that. It will now have a steeper slope. And the new equation for this line will be 30 times the number of discs she buys plus 30 times the number of games she buys is equal to 60.
The segment you are about to watch contains numerous algebraic formulas. Viewer discretion is advised.
The budget constraint can also be given algebraically. Here's the equation. I is equal to the price of CDs times the quantity of CDs plus the price of games times the quantity of games. In the equation, I represents income and P represents the price of CDs and games respectively. CD and games stand for the quantities. For example, if the price of CDs is $15 each and the price of games is $30 each, our income of $60 can be split as $60 is equal to 15 times CDs plus 30 times games. To make this more familiar, let's solve for CDs as the dependent variable. Here we have the equation that 15 CDs is equal to 60 minus 30 times games. This says the money spent on CDs equals the income remaining after purchasing games. Dividing through by 15, the price of CDs, we get the following equation. So CDs is equal to 4 minus 2 times games. This means that the number of CDs we can purchase equals 4 minus 2 times the number of games that we can buy. So if Heather spends all of her money on CDs, she can buy 4. Mathematically, this means that the y-intercept, where the budget constraint intersects the vertical axis, is 4, and the slope of the constraint is minus 2. The slope reflects the trade-off between CDs and games. For each additional game she buys, she must give up 2 CDs. Well, this makes sense since the price of a game is twice that of the price of a CD. Now, let's put this equation into a more general form. Games is equal to 60 divided by 15 minus 30 divided by 15 times games, which is equal to 4 minus 2 times games. Notice that Heather's ability to purchase both CDs and games is affected by the prices of CDs and games, and the amount of income she receives. Well, let's examine what happens when each of these change. First, suppose there's a sale on compact discs, and they are now priced at $10 apiece. Algebraically, this has the following effect. Recall that the equation for CDs is equal to income over the price of CDs minus the price of games divided by the price of CDs, which was 60 over 15. Minus 30 over 15 times games, which is equal to 4 minus 2 games. Now, since the price of CDs equals 10, we get a new budget constraint. Here we see the equation where CDs is equal to income over the price of CDs minus the price of games over the price of CDs as before. Well, this is equal to 60 divided by 10 minus 30 divided by 10 times games, or 6 minus 3 times games. The effect of the decline in the price of CDs means that Heather could purchase more if she spent all her money on CDs, so the budget line swings out. Here we see the effect of a decrease in the price of CDs. The new y-intercept is 5, and the slope is now minus 2.5. So if Heather spends all her money on CDs, she can now purchase 5, and for each additional game she purchases, she must give up 2.5 CDs. Similarly, if the price of CDs were to suddenly rise, say to $30, Heather could only purchase 2. In this case, the budget line swings in, and Heather can purchase at most 2 CDs. The effect of a decrease in the price of games to $20 has a similar effect. So this time we'll keep CD prices at the original level of $15. So we have the equation that CDs, which is equal to income over the price of CDs, minus the price of games over the price of CDs, is equal to 60 over 15 minus 20 over 15 times games, which is 4 minus 1.33 times games. In this case, the slope changes to 1.33, meaning that for every software game she purchases, she's giving up 1 1/3 CDs. Since software is now less, if Heather were to spend all her income on software, she could now purchase 3. So the budget line once again swings out along the x-axis. Similarly, if software increased to $40, Heather could only purchase 1.5 if she spent all her income on games. Once again, the budget line would swing in along the x-axis. But what happens if income changes? Well, of course, you could buy more goods. So this time, let's increase income to $90 and see what happens. And income shifts the budget constraint out, changing the intercepts but not the slope. In other words, a change in the income causes a parallel shift in the budget line. A parallel shift means that the slope remains unchanged, so prices remain the same. Assume that the price of CDs is 15 and the price of games is 30. We now get the new equation that CDs, which is equal to income over the price of CDs, minus the price of games over the price of CDs, is equal to 90 over 15 minus 30 over 15 times game, or 6 minus 2 times games. The area between the two budget lines represents the increase in possibilities as a result of this change in income. Simply by looking at the feasible choices available to an individual, we can eliminate a lot of possibilities without even understanding how a person makes a decision. But this still leaves us with an almost limitless number of possibilities within a person's purchasing power. All the options along the budget line. To find the exact choice, we need to know more about how an individual values one good versus another. The following tables help illustrate this meaning. Let's assume again that Heather has $60 with which to purchase CDs and software. First, we need to know something about Heather's preferences. We can do this most easily by asking her to assign values to CDs and to software for different quantities. In this table, the first column is the quantity, the second column is the marginal utility of CDs. The third column is the price of CDs, and the fourth column is the marginal utility divided by the price of CDs. So the fourth column informs us about the utility derived from each dollar spent on that particular item. For example, we purchase the first CD at $15 and get 75 utils. So each dollar spent gives us 5 utils. If we purchase 2 CDs, it is as though the last dollar spent on CDs gives us 4 utils, and so on. Continuing in this way, the fifth column is the marginal utility of games, the fifth, the price of games, and the sixth column, the utility of games over price. But how do we determine the maximum utility? Well, that happens where the marginal utility over the price for CDs is equal to the marginal utility over the price for games. In other words, it occurs where the last dollar spent on CDs gives us the same utility as the last dollar spent on games. So what combination of CDs and games will Heather buy? Remember, we have to stay within our budget. We can purchase 4 CDs and 0 games. Does this maximize utility? Well, no. The last dollar spent on CDs gives us 2 utils. We would have done better had we bought at least 1 game, which gives us 4 utils per dollar. But we would have to cut back by 2 CDs. Still, this is a good deal more, for the decline in satisfaction by buying fewer CDs is outweighed by the increase in satisfaction by buying more games. In fact, the marginal utility per dollar is equal at a quantity of 2 CDs and 1 game, and we've also exhausted our income. Dave responds, "It makes no difference to me, whatever you want." So she asks James. James responds the same way, "I don't care, I'll eat whatever Dave wants." Well, Heather realizes this could go on all night, and although they may come back at her and blame her for dinner, she decides to go out on a limb. She says, "I'll decide." Well, Heather loves pizza and diet soda. Each slice of pizza costs $2 and each soda costs $1. Heather has $13. Well, from what we learned earlier, her budget constraint is given by this equation. 13 is equal to 2 times pizza plus 1 times soda. So here the number of sodas Heather can buy depends on what's left over after buying pizza. So soda is equal to 13 minus 2 times pizza. Heather receives different amounts of utility for each good, but as indicated by the principle of diminishing marginal utility, she receives more utility from consuming the first unit of each good. As she continues eating or drinking, she eventually gets full and her utility declines. This table shows her utility. In the table, we see the quantity of pizza and soda that goes from 1 to 8 units. In the next column, we see the total utility from pizza, and that goes from 20 utils to 45 utils. Based on the data from the second column, we get the third column, which is the marginal utility of pizza. For example, the marginal utility from the second pizza is 10, which is the difference between 30 and 20. In the fourth column, we see total utility from soda, and that goes from 10 to 24 utils. And based on this, we derive the last column, the marginal utility from soda. Notice that at 7 sodas, marginal utility is negative. That's because Heather has reached a point of satiation. By increasing sodas from 6 to 7, utility drops from 30 to 28. Keep in mind that Heather's decision problem is to figure out the mix or bundle of soda and pizza that maximizes her total utility. Well, there are a couple of ways we can figure out which bundle will solve the problem. At first glance, we could simply add the utilities for each affordable bundle. For example, the combination of 3 pizzas and 7 sodas is within budget. Heather gets 20 utils from the pizza and 28 utils from the soda for a total of 48 utils. Or she could buy 6 pizzas and 1 soda for a total utility of 54. This is also within budget. Continuing, we see that the combination of 4 pizzas and 5 sodas gives 69 utils of satisfaction. Based on this approach, we find that the optimal combination is 4 pizzas and 5 sodas. But there's an easier way of determining the optimal commodity bundle. We know she will not consume more than 6 sodas since these would actually reduce her utility. We also know that she's limited by her budget constraint and the fact that each decision to consume a soda means she must give up some pizza and vice versa. But how will she decide between the feasible choices? What it comes down to is that she wants to get the most utility from each dollar she spends. Thus, for each unit, she must determine how much utility per dollar spent is obtained. Or she's looking at the marginal utility of soda over the price of soda and comparing that with the marginal utility of pizza over the price of pizza, or marginal utility per dollar spent. As long as Heather can get more utility per dollar from consuming pizza than soda, she'll consume pizza and allocate her resources towards pizza and away from soda. Well, let's look at her possibilities again. Remember that Heather has only $13 to spend. Well, let's begin by assuming she decides to buy 6 slices of pizza and 1 can of soda. Her total utility is 54. Her last piece of pizza yielded 2 utils. It costs her $2. So the last dollar spent on pizza yielded 1 util. The can of soda she purchased yielded 10 utils. In this case, Heather could benefit by substituting soda for pizza. By purchasing 1 less pizza, she loses 2 utils. Using that $2 she saved from buying 1 less pizza and purchasing 2 more sodas, she gains 14 utils. So purchasing 5 pizzas and 3 sodas increases her total utility to 12. Total utility rises to 66, but she still hasn't maximized utility. By giving up the 5th slice of pizza, she gives up 3 utils. By using the $2 she saves and buying 2 more cans of sodas, she gains 6 utils. So total utility increases by 3 to 69. Should Heather give up the 4th slice of pizza? Well, let's see. The marginal utility of the 4th slice is 4 utils, so she'd be giving up 4. Reallocating the $2 saved to purchase soda would result in negative utility of -2. Her net loss would be 6 utils. Thus, she will consume 4 slices of pizza and 5 sodas with her $13. More generally, individuals will attempt to spend their income such that they equate their marginal utilities per dollar across all goods. We can rearrange this equation by multiplying both sides of the equation by px and dividing both sides of the equation by the marginal utility of y. But what we see is the utility maximizing rule. The ratio of the marginal utility of x to the marginal utility of y, the left side of the equation, is called the marginal rate of substitution. It's the rate at which an individual is willing to give up y for an additional unit of x. And what this equation says is that in equilibrium for a maximizing individual, this will be equal to the price ratio between x and y. Well, what does that mean? It means that the relative prices equal the relative marginal utilities. The greater the price, presumably, the greater the marginal utility from that good. And the lower the price, the lower the marginal utility. Let's review. We wanted to make the idea of rational choice more realistic by introducing the budget constraint and the idea of purchasing more than one good. First, we introduced the concept of the constraint. The budget constraint shows the different combinations of goods that an individual can purchase, assuming that money income is held constant. Second, we noted the effect that changing prices have on the constraint. An increase in the price of one good causes the constraint to swing inwards. A declining price causes this curve to swing out. We say swing because a change in the price of one good alters how much you can purchase of that good, but does not alter how much you can buy of the other. Third, we noted the impact of a changing income on the constraint. A rising income shifts the curve outward. A declining income shifts the curve inward. Fourth, we observed the decision-making process when we introduced more than one good. In our example, Heather sought to allocate her income such that the last dollar spent on one good yielded the same utility as the last dollar spent on the other. If there is a difference, we can increase total utility by substituting one good for another. And finally, we saw a result that we discovered in our last segment. Relative prices equal relative marginal utilities. If you're willing to pay more for one good than another, it must yield a greater marginal utility than the other.